hearty welcome to all of you to this very important video, which is going to be very long. We discuss here the digital image processing, how we are going to simplify it without using so much of techniques or equations and all those things, but we will discuss the important things which makes the image processing concepts very simplified. Let me go through point by point here. The motivation for the subject here of digital image processing is a picture is worth 1,000 words. It means whatever the picture you take, it gives us the entire explanation without in place of writing 1,000 words, and it has been coined by Henrik Ibsen. This particular thing, already it was there in the literature, but it was coined by Mr. Henrik Ibsen. Let us go to the points where basics everyone must know here in the digital image processing. Very first thing, image perception is based upon eye vision. How the how the eye structure is completely made up of, like how we have the lens, the retina, the macula, the fovea, all the components of the eye, like rods and cone pigments. Rods are useful for brightness adjustment. Cone pigments are useful for understanding the colors like red, green, and blue. Means image perception is completely based upon the eye vision. On the same lines, the cameras were also developed. Next point is that all the images that are available in the nature are of 3D. There is 3 dimensions, but they are visible to us in the form of 2 dimensions, because on the 3rd dimension we are standing on that one and we are seeing the 2 remaining dimensions here. You can understand this one by looking at the corner of any room. For example, you take the corner of any room, it looks like 3 dimension. On the one axis of that one, we are standing and looking at that one corner. That is how the image or the sceneries look like. Next one, image is also a function, just like signal, as we might have studied in our engineering concept. Signal is a function. Similarly, image is also a function, whereas signal is a one-dimensional function, whereas image is a 2-dimensional function, which is made up of purely pixels and a number of levels. And the last one, which is very familiar to everyone, even the layman understands this word, is image resolution. How we see the information in the image, how much clear we are able to see that, it clearly depends upon the resolution. And why I am saying it is everyone knows it. We have the mobile cameras, we have the cameras, DSLR cameras, all of them. We discuss about this word resolution like 64 megapixels, 128 megapixels, like that. Basic, we know image resolution, how much it must be. Very next thing here, it is main components of image everyone must know. Very first thing here is pixels. Pixels, nothing but picture elements. Picture elements. In the picture elements, pic is taken in the first word. In elements, the first 2 letters are taken. L. Pic, L, nothing but pixel. The another short form for pixels is pels. Actually, the pixels are very important things, which gives us the clarity about as many as the pixels are available at the particular scenery, as that much the image is very clear to us. And the second one is type of the image. However, we'll discuss about this one in the later. The type of the image means, is it a binary image or a grayscale image or a color image? Which type of image we have to be taken? It is the type of the image tells us what is going to happen in the image processing. Next is format of the image. Everyone knows it. JPG format, PNG format, TIF format. We tell so many of these words. Here we have to think about which type of format, and the format of the images depends upon the type of application you are using. For example, most of the website or most of the what you call network security images are used up of .png format, whereas the normal pictures or the normal photos what we take are of the JPG format. Like that, we have different type formats of the images. Next one, coming to image attributes. Here image attributes means brightness, contrast, saturation, intensity. As all of us know from our televisions or the monitors in the home, how we measure how we adjust the brightness such that we watch the scenes on the television clearly. Similarly, contrast, saturation, hue, intensity, these are all the image attributes one must know. This means these four are the main components of an image. The very first stage here in digital image processing, we are going to discuss fundamental stages. In that one, very first stage is image acquisition. We have to discuss about image acquisition, how the steps are involved here. Very first one, type of modality used. Modality means type of the device used to capture an image. Actually, it depends upon the type of application. Now, there are so many devices like normal camera, either for photograph or videograph, whereas medical type of cameras which uses the CT scan, computer tomography, magnetic resonance imaging, like that, depending upon the type of modality. Very first one, acquisition depends on. Next one, what are the sensors available or involved while taking the or capturing the image? Like it is a linear sensor or array type of sensor. It depends. Each type of sensors are utilized in the device to capture an image. Next one, as I said earlier, application type. If it is any medical imaging type, we go for X-ray, we go for computer tomography. If it is for satellite type of imaging, we go for the aerial photography pictures. If it is any like we have to understand the what you call how much is the concentration of any object or what is the strength of the wall. We use thermal imaging materials or cameras that we call as infrared cameras. Next one, image formation. It is very important in image acquisition how the image is formed. The image is formed mainly based upon the eye vision, how we capture the image from. And in this image formation, the main point to be remembered is the illuminance. Illuminance means in general language, we say if you go to a studio, they have some focus lights or flashlights that mainly focus onto the object. Object means scenery here, and the camera lens start to work. This is how the image formation mainly depends upon a main parameter called as illuminance. Keep it in mind, illuminance. Next, what are the types of the images we are having? Very first one is the binary image. Here, binary image means zeros and ones. Images made up of zeros and ones. Here, zero represents the black or dark, whereas the one represents the brightest one. Just simple, dark and white, black and white, simple. When it comes to grayscale or gray shade or gray level or intensity type of image, there are so many names for this type of image. In general, the old black and white photographs what we have with us are of gray shaded images. And these grayscale values have the range between 0 to 255, those values. But human eye can identify only 40 shades. And the last but not the least is the RGB image, which is referred as red, green, blue image. Why It is actually also called as true color or color image. Why RGB is very important here is the eye also have three cone pigments, namely red cone pigment, green cone pigment, blue cone pigment. That's why red, green, blue are referred as basic or primary colors of image processing. That's why we prefer RGB as the name. From RGB, on combination of R plus G, then R G plus B or B plus R, we get secondary colors. Like that, we use the combination of these three colors based upon the type of application we are going to do. This is how the types of images are explained here. Now, we should understand what are the types of images: binary scale image, binary image, grayscale image, and what do you call red, green, blue image, which is actually called as color image. Now, as a second step, we move towards image enhancement stage in 2 as image enhancement after image acquisition. In this mode, very first of all, let us know why we go for image enhancement procedures. Very first thing, we have to enhance means improvise the hidden information in the picture, in the image, or in the scenery, whatever we have captured. Sometimes it may be disturbed due to the internal issues or external issues like atmosphere, fog, all those things. And the second one is filter important image features, means it will improvise the important image features which are not visible while we have taken the image, that is captured the image. The next stage is discard the unimportant image features, means here completely avoid whatever is the unimportant there, just avoid that particular concept, particular features, and only highlight or go through the things which are required for us to analyze one image, that these things are very important for particular applications. Like that, these are the three important things why we go for image enhancement. Next, what are the 5 drivers of image enhancement? Means what are the main image enhancement factors, which is called as 5 drivers. Very first one, dynamic range of intensity values, limited number of bit planes. Means intensity values here, we know from our basic television knowledge while looking at a image or video, how the brightness, contrast, and all those things changes with respect to the intensity, and what are the required values were in. For example, if you take gray shade, we require 0 to 255, means as much as the intensity values, as much as the better the perception will be. Second one, varying illumination over the image space. Here already I have informed to you in the beginning of image acquisition, illumination means it is just like a flash device for our flashing of the light while we are taking a image or picture or capturing a photo. That illumination will vary. This is also varying of illumination might also affect on the image, that will lead us to enhancement. Next one, brightness, very well known factor to everyone, even a normal one, a normal man, that is layman also, who is utilizing the television, knows this particular factor. We know how to increase, that is like a sunshine, or how we pursue brightness. Next one, contrast. See, the brightness and contrast are very confused words for all of us. Brightness is to increase the range of whiteness, I can say whiteness, white shade, whereas contrast is improves the quality of the image, along with it will control or adjust both whiteness as darkness in the image. That is the difference between brightness and contrast, that everyone should know about it. Next one is color. And even the olden days, we used to have the old movies which are made up of black and white, which are of not so important, because the color factor in any image gives us the important information what we are going to pursue from it. That is why color is an important aspect. and it tells us a lot of things because each and every color have their own intensity values, their own brightness and contrast values. Now coming to the stage 3 of digital image processing, referred as image restoration. It is one of the most application oriented stage. What is image restoration? Before going to image restoration, let me tell you what are the things. Very first thing, it is used to restore a degraded image back to the original image. Means, for example, most of the old monuments which have been dilapidated mainly due to atmospheric changes or some overlong disputes or some other issues, damaged or anything like old monuments, old pictures in the old monuments, old buildings, those can be virtually restored if we know what we have to restore. Means we can get the original image but in virtual mode. This is how image restoration works on. We can take a lot of examples where the old monuments, old museums in the world have been restored based upon this method. Next one, just now we have seen the image enhancement, whereas image enhancement is to manipulate the image so that we can see the hidden things available there. But image restoration is to getting back to the originality of the image. There is a small change from restoration to image enhancement. Means, I said old monuments, archaeological departments in the world utilize this restoration process to go through their history and see that how was it in the history and how it is now, and try to restore it to its original form. Next one is, let us know about image restoration. Here it, as I already said, it attempts to restore the image or scenes which have been distorted or degraded by some means of internal issues or external issues like atmosphere, decay in the material, all those things. In this one, first of all, we have to identify what is the degradation process that has been happened. Is it due to atmospherical changes? Is it due to manual changes or man-made changes to that particular picture? And then we can attempt it to reverse it. Now, it is similar to image enhancement, but more objective in wise. Means, in image enhancement also, we try to enhance the hidden features. But here, along with the enhancing the hidden features, we work on each and important feature like attributes in the image. Like, for example, if you take a monument of some, what you call the kings of mummies in Egypt, how was their nose, how was their ears, how was their eyebrows, all these important aspects of a picture will be considered into. That's why it is called as, when compared to image enhancement, image restoration is more objective. This is the simplest of the diagrams, which helps us to understand how the degradation and restoration process happens. This is mainly due to, whenever you give the original image, look at that point there, degradation function. Once the noise may be additive and it has to be restored in the filter once we know what is the noise and we can restore the image. Let us go through the noise models. What are the sources of noise that might come into existence and distort our images? Very first one, during image acquisition, sensors can be damaged due to ambient condition. Damage means they can work in another mode due to ambient conditions like atmospheric changes. Like if you are taking a picture during the rainy day, it might be somewhat less brightness there. Next one, during image transmission, means interference can be come in between, like added noise can be carried out during the transmission process. Next one, spatial properties of noise. What are the spatial properties? When it comes to spatial properties, if you take a gray level, it's pixels, how they behave with respect to their values. That is statistical behavior, we call it as. Next, noise parameters, and those noise parameters, their correlation with the image. Next one, frequency properties of noise. First of all, we have seen the spatial properties. Next, frequency properties. Mainly, Here we depend upon the Fourier spectrum, means Fourier transform. And the best example for this one is the white noise is the best example for the noise models in frequency properties. Next, coming to the noise models, what are the types of noise models we have? Look in literature. Very first one, Gaussian. This Gaussian leads to poor illumination. If this Gaussian noise is added during the transmission, it will lead to very poor illumination. Whereas if the relay is there, the image range might be disturbed. If it is gamma type of noise or exponential type of noise, it is more involved in laser type of imaging. When it comes to impulse, it may gives rise to faulty switch. Faulty switch means if it is 0, it gives 1. If it is 1, it gives 0. Like that, the bit values of image changes, binary values of image changes. Similarly, if it is uniform noise is added, but when it comes to uniform noise, it is considered as the least used among them. And the Gaussian is the most interfered noise model we have in the image processing and image restoration process. Now, as a second step, we move towards image enhancement, stage M2 as image enhancement after image acquisition. In this mode, very first of all, let us know why we go for image enhancement procedures. Very first thing, we have to enhance means improvise the hidden information in the picture, in the image, or in the scenery, whatever we have captured. Sometimes it may be disturbed due to the internal issues or external issues like atmosphere, fog, all those things. And the second one is filter important image features, means it will improvise the important image features which are not visible while we have taken the image, that is captured the image. The next stage is discard the unimportant image features, means here completely avoid whatever is the unimportant there, just avoid that particular concept, particular features, and only highlight or go through the things which are required for us to analyze one image, that these things are very important for particular applications. Like that, these are the 3 important things why we go for image enhancement. Next, what are the 5 drivers of image enhancement? Means what are the main image enhancement factors, which is called as 5 drivers. Very first one, dynamic range of intensity values, limited number of bit planes. Means intensity values here, we know from our basic television knowledge while looking at a image or video, how the brightness, contrast, and all those things changes with respect to the intensity. And what are the required values for it? For example, if you take gray shade, we require 0 to 255, means as much as the intensity values, as much as the better the perception will be. Second one, varying illumination over the image space. Here, already I have informed to you in the beginning of image acquisition, illumination means it is just like a flash device for our flashing of the light while we are taking a image or picture or capturing a photo. That illumination will vary. This is also varying of illumination might also affect on the image, that will lead us to enhancement. Next one, brightness, very well known factor to everyone, even a normal man, that is layman also, who is utilizing the television, knows this particular factor. We know how to increase, that is like a sunshine, or how we pursue brightness. Next one, contrast. See, the brightness and contrast are very confused words for all of us. Brightness is to increase the range of whiteness, I can say whiteness, white shade. Whereas contrast is improves the quality of the image, along with it will control or adjust both whiteness as darkness in the image. That is the difference between brightness and contrast, that everyone should know about it. Next one is color. And even the olden days, we used to have the old movies which are made up of black and white, which are of not so important, because the color factor in any image gives us the important information what we are going to pursue from it.
That is why color is an important aspect, and it tells us a lot of things, because each and every color have their own intensity values, their own brightness and contrast values. Now coming to the stage 3 of digital image processing, referred as image restoration. It is one of the most application oriented stage. What is image restoration? Before going to image restoration, let me tell you what are the things. Very first thing, it is used to restore a degraded image back to the original image. Means, for example, most of the old monuments which are being dilapidated mainly due to atmospheric changes or some overlong disputes or some other issues, damaged or anything like old monuments, old pictures in the old monuments, old buildings, those can be virtually restored if we know what we have to restore. Means we can get the original image but in virtual mode. This is how image restoration works on. We can take a lot of examples where the old monuments, old museums in the world have been restored based upon this method. Next one, just now we have seen the image enhancement, whereas image enhancement is to manipulate the image so that we can see the hidden things available there. But image restoration is to getting back to the originality of the image. There is a small change from restoration to image enhancement. Means, I said old monuments, archaeological departments in the world utilize this restoration process to go through their history and see that how was it in the history and how it is now, and try to restore it to its original form. Next one is, let us know about image restoration. Here it, as I already said, it attempts to restore the image or scenes which have been distorted or degraded by some means of internal issues or external issues like atmosphere, decay in the material, all those things. In this one, first of all, we have to identify what is the degradation process that has been happening. Is it due to atmospheric changes? Is it due to manual changes or man-made changes to that particular picture? And then we can attempt it to reverse it. Now, it is similar to image enhancement, but more objective in wise. Means, in image enhancement also, we try to enhance the hidden features. But here, along with the enhancing the hidden features, we work on each and important feature like attributes in the image. Like, for example, if you take a monument of some, what you call the kings of mummies in Egypt, how was their nose, how was their ears, how was their eyebrows, all these important aspects of a picture will be considered into it. That's why it is called as, when compared to image enhancement, image restoration is more objective. This is the simplest of the diagrams, which helps us to understand how the degradation and restoration process happens. This is mainly due to, whenever you give the original image, look at that point there, degradation function. Once the noise may be additive and it has to be restored in the filter once we know what is the noise and we can restore the image. Let us go through the noise models. What are the sources of noise that might come into existence and distort our images? Very first one, during image acquisition, sensors can be damaged due to ambient condition. Damaged means they can work in another mode due to ambient conditions like atmospheric changes. Like if you are taking a picture during the rainy day, it might be somewhat less brightness there. Next one, during image transmission, means interference can be come in between, like added noise can be carried out during the transmission process. Next one, spatial properties of noise. What are the spatial properties? When it comes to spatial properties, if you take a gray level, it's pixels, how they behave with respect to their values. That is statistical behavior, we call it as. Next, noise parameters, and those noise parameters, their correlation with the image. Next one, frequency properties of noise. First of all, we have seen the spatial properties, next frequency properties. Mainly here we depend upon the Fourier spectrum, means Fourier transform. And the best example for this one is the white noise is the best example for the noise models in frequency properties. Next, coming to the noise models, what are the types of noise models we have? Look in literature. Very first one, Gaussian. This Gaussian leads to poor illumination. If this Gaussian noise is added during the transmission, it will lead to very poor illumination. Whereas if the relay is there, the image range might be disturbed. If it is gamma type of noise or exponential type of noise, it is more involved in laser type of imaging. When it comes to impulse, it might gives rise to faulty switch. Faulty switch means if it is 0, it gives 1. If it is 1, it gives 0. Like that, the bit values of image changes, binary values of image changes. Similarly, if it uniform noise is added, but when it comes to uniform noise, it is considered as the least used among them, and the Gaussian is the most interfered noise model we have in the image processing and image restoration process. Now coming to the stage 4 in digital image processing, which is referred as image segmentation. Actually, image segmentation is preferred as the most important post-processing method in all of the image processing applications. After pre-processing, that is image enhancement method is applied, post-processing, image segmentation is the best method. Very first thing, let us go to the introduction of image segmentation. Actually, what do happen in segmentation is it divides an image into regions. There is a misconception that image segmentation means it divides image into so many multiple images. Not. It divides into regions of objects of interest, of region of interest. For example, if you take a medical image of having some tumor or anything like that, it will segment according to an algorithm provided there, only the tumor there. Like that, region of interest is the very important word that comes into picture in image segmentation. And now coming to the basic properties of intensity values in the image segmentation process. Very first thing is discontinuity and similarity. Means regions or objects are divided based upon two basic properties. That is, one is discontinuity, means in an image there might be some discontinuities, means edge detection, edges might be separated. Next, coming to the similarity. Here similarity means if the region of interests are of same, then we go for the thresholding. After getting that one, we go for region based segmentation. That is, as per region of interest, we go to growing as well as splitting as well as merging, depending upon the type of application we are bothered about. Now coming to the segmentation problem here, what is the problem that arises? Very first thing, it tries to partition the pixels of an image into some clusters, that is groups, which can clearly say that it is an object in an image. Once again repeating the word, it is an object, means it is region of interest in those pixels are divided into groups or clusters. Why I'm saying groups means depending upon the type of pixels available in the image scenery. Next one, as I said, in the segmentation problem or the image segmentation is the very first step in any computer vision applications, because once after pre-processing, image segmentation gives us how to identify the things depending upon the application. Medical means what is the abnormality there. If satellite means depending upon the satellite imagery, whether water is available there, whether vegetation is available there, whether barren lands are available there in the picture of satellite or aerial images. Like that, region of interest is mainly based upon the image segmentation algorithms in digital image processing. This one is the one example I wanted to show you here, how the image segmentation is carried out in a simple example of the kinds. You can see that how it is depending upon the objects, as the kinds are considered as the objects here, those are done with segmentation application. Very first one, next one here it is, as I explained you in the previous section, discontinuities, similarity and discontinuities. In the discontinuities, once again, it divides into three parts. What are the discontinuities in an image? There might be points, lines, and edges. Most of the times, the discontinuities, whether it be point or line or edge in an image, are identified by using the masking operation or carrying out the correlation as we do in the normal signal processing. Next, we go towards, before going to image compression, the next stage, I would like to say that image detection, image segmentation is very important aspect in image processing, which deals with a region of interest in all the applications of image processing. And keep it in mind that segmentation means not dividing the image into so many images. Image segmentation means dividing it into region of interest. That is how it is carried out. Moving from image segmentation stage towards image compression, stage 5 in digital image processing. Here, the main intention of image compression is to reduce the amount of redundant information in an image. And whatever the redundant information is available, we can remove it and compress it. And mainly, it changes the difference in the mainly during transmission process as well as in the storage process. It shows a lot of change. That is the main intention behind the method called image compression in digital image processing. This is the simplest of the diagrams one can explain you. Here f of x comma y represents the original image. It is undergone a compression algorithm. There are so many compression algorithms. We undergo any one of the compression algorithms. You can see the two processes available there. One is transmit, one more is storage device. Just now, as I said, during transmit also it makes a lot of difference. During storage device also it makes a lot of difference. Now, during retrieval, it is going to be recompressed such that we receive at the end, and we should choose the image compression algorithm such that the restored image given by here in the picture as f cap of x comma y is somewhat nearer to the original image that has been utilized for compression process and not more. And also we should be careful with so many parameters are available in the research nowadays to identify how much the compression ratio has happened, how much is required, or which type of algorithm is better for which type of application. It depends upon applications here. Moving from this image compression, why it is so? Very first, let us go through the types of them. Very first type is lossless here. Lossless image compression methods. Here in this lossless image compression methods, very first thing is information preserving. As the word tells, lossless image compression. The information preserving means whatever the features or attributes in an image are restored even though we go with. Whereas compression ratios are very less here because it is a lossless type of image compression. Later, we go towards lossy type of information. Here, information loss is more, means the data or the features available will be more, but kept in mind that the data whatever has been removed, it is most of the times the redundant data, repetition data in an image. And whereas the compression ratios are very high in nature or subjective wise. The trade-off in the image compression is mainly always done between information loss to its compression ratio. Always we should have a graphical analysis with respect to how much information is lost to its compression ratio. If it is optimal, then only we should go to a particular type of image compression algorithm. Otherwise, we should not go to it. That is the main thing we should remember in image compression. Before going to color image processing, let me give you a few more guidelines regarding image compression. In image compression, we should be careful with respect to the type of the image that has been considered and with respect to its what you call application also. If most of the times, if you are transmitting on medical image through, keep it in mind that most of the times there is less amount of information is lost. Whereas some of the normal images, day-to-day images, what we take, even though there is much loss of information is available, is carried out, that bothers not, that doesn't bother more for any application. Whereas coming to the most application oriented is there will be medical or satellite or agriculture things. We should be kept in mind that what are our requirements, what are our prerequisites. This is how image compression algorithms must be carried out. Most of the times, image compression algorithms are based upon how we reduce the information, that is redundant information, and carry. In this process, we are going to save the memory in the storage devices also. There is one point we should take care while going through image compression algorithms. As I once again repeat you, the main thing is that we have to identify which method is best based upon a trade-off parameter, that is information loss versus compression ratio. We should have a good tabular column as well as a graphical analysis. Then only we shall consider which type of image compression algorithm is best suited for. And I request you, while going through image compression algorithms, keep it in mind which type of image is also carried out. Now coming towards the stage 6, color image processing, which is of very interest because this has the tendency to explain us the more depth of the images, what are they, how they are doing out. Very first, primary and secondary colors, what are they? In 1931, the International Commission on Illumination, that is represented as CIE, has defined the wavelength ranges to define the types of the colors available in the images. Very first, the primary colors. Look at this range there. Blue, B represents blue here, 435.8 nanometers. G represents green here, 546.1 nanometers. R represents red here, which is 700 nanometers wavelength. However, we know that no single color may be called red, green, or blue. Very important statement here. Keep in mind that while the color image processing has evolved with respect to color televisions, we used to call Eastman color, and also red, green, blue are the icon segments or icon pigments available in human anatomy. Because of that, red, green, and blue are referred as the primary colors. Next, secondary colors. The secondary colors are derived using the combination of the primary colors, whereas addition of green and blue gives rise to cyan, whereas addition of red and green leads us to yellow color, whereas red and blue leads us to magenta, which the cyan, yellow, magenta or cyan, magenta, yellow, CM model or colors are represented as secondary colors, as RGB are represented as primary, CM represented as secondary colors. Now let us understand how the human eye senses the light, means how it achieves or attributes the colors. In human eye, there are 6 to 7 million of cones are the color sensors in the human eye. In simple terms, we can say cone pigments are available. The picture available here shows the colors vigour, that is violet to red, how each and every color have their wavelengths, and the red color is having the more wavelength. That's why the red color is most preferably used in all of the alert systems or alert applications in the world, whereas the green and blue follows the red color in terms of absorption through the eye. Very first one, the principal sensing categories in eyes are, very first one, 65% of all the cone pigments refers as red light. means sensitive to the red light. That's why red alert systems. Now 33% towards green light and 2% to blue light. That is the reason why in the nature also you find red and green color more in abundant in availability, whereas blue color in nature is very less for our abundancy also. This is the one of the main reasons why blue color is very less available in the nature also. Next, a myth in color image processing. It is a very big question arises from the olden days. Is it true that some of the animals tries to attack the human beings based upon their color codes or color dresses? Also, yes, the answer is yes. Why it happens? It mainly depends upon the cone pigments. As I already said, red, green, and blue pigments are available in the human eye anatomy. These, if any changes in any of the cone pigment has happened, this leads to the color blindness, means that particular animal, some of the animals don't have as many as of the color cone pigments as the human eye. Some of them have more, but some of them have less. That's why whenever we did dress, color dress, some like big animals like ox and buffaloes that try to attack, it is a myth, but it is not a myth. It is a true fact that the attacks based upon the colors. And I wrote the word here colorblind to explain you that how the colorblind happens because of a loss of even a small percentage of one cone pigment available in the eye. Next, color models. What are the types of color models we have in color image processing and what is its purpose? Very first thing we have to discuss about the purpose. Now, to understand the specific colors as per their standards, we have different color models and their applications also comes into picture here. Very first one, RGB models. The RGB color model has come into existence mainly based upon the monitors, let it be PC monitor or television monitor. In the applications of these, the RGB models are most preferably used. Second one, CMY. In the bracket, I have to CMYK. CMY means cyan, magenta, yellow, whereas K represents the black color. Here, this type of model is mainly used in the printing process. If you go to a printing press or printing machine of color, you will be having these colors to be filled in that one. And one more application I would like to highlight here is the paint shops. If you go to the paint shop and ask for a particular color I would like to have for my walls, they'll show you some shades which looks similar, but a small intensity changes will be there. And when you ask them, please give me that color or this color, then you have to go through the leaflet what they show us to us. Depending upon the percentages, they mix these primary colors or secondary colors and they give us the main color for having the paint. Next one, YVV, mainly for color televisions, the color models. Next one, HSI, represents hue, saturation, and intensity. Hue, saturation, intensity are very important parameters in an image, which gives us the perception of image in very good way. Means it can try to intercept the colors also. Before going to the stage 7 of morphological image processing, I would like to stress on color models that one should be very good with the types of primary colors, that is RGB, primary secondary colors CMY, and their applications where they are most preferably used and why they are in prevalence. Now moving from the previous color image processing, here in stage 7 we are about to see morphological image processing, which is mainly based upon the shape-based science actually. Now let us go to the introduction points here. What is meant by morphological image processing? Now, as I said, it is a shape-based image processing based on mathematical morphology, and it has been in use before. It has been introduced in the morphological image processing as a part of mathematics where the functions are to be converted as per the convenience of the application, like changing their zones and regions in mathematics also. Now, mainly, this morphological image processing has been derived from a word called morph. Morph or morphing means changing shape of the particular image with respect to the regions. Next, the morphological image processing is mainly useful in representation and description of region shape, means how the region shape must be, and it is useful in having the discussion of the image, that is shape of the image. Next, what are the main factors of morphology? The main factor of morphology is structuring element, which is referred as structuring element, which acts as a masking one, and it changes as a mask having some 3x3 or 4x4 array. It will mask on each and every part of the image and operates some of the operations which we are going to see in the next slides. Very first thing is a structuring element is nothing but a small type of set of the same image which is under the investigation, means which is has to be morphed or changed, and this structuring element is mainly adapted with respect to the geometric properties of the image, like what are the x plane, what are the y plane, what is the z plane. We take those geometric properties and then the morphology is mainly adapted to geometric properties. Now let us come to the very interesting aspect of morphological image processing, referred as morphological operations. Very first one is erosion operation. This erosion is nothing but like a shrink in an entire image. So some of the object is meant to be shrink or reduce in shape with respect to its shape. Next one, dilation. It is simple, it is grow in shape. Any of the objects in an image or regions are meant to be grown in shape. That is called as dilation operation. Next one is opening. Here, this two erosion and dilation. Next we come across two operations which are the combination of erosion and dilation. Very first one is opening, which is the combination of erosion followed by dilation. Next one, closing, dilation followed by erosion. Means in opening process, we do first of all dilation then erosion. Here we do erosion and then dilation. This is the simplest of the way, is having the both of the things, and mainly the smooth contours and the shapes which are having some absurdities are computed with the help of operations. Next one, moving towards after the stages of morphological image processing, let us have the stages of digital image processing. Let us discuss about some of the applications of digital image processing. Moving towards application, here very first thing is biomedical image processing. This biomedical image processing has been one of the very important applications of digital image processing, where we tend to identify the abnormalities and we try to forecast them beforehand such that we can carry out the treatment and save their lives. These are the places where biomedical image processing, this digital image processing is utilized in applications. Not only abnormalities, even it can induce what were the causes that has been led to the ailments. And here the very famous modalities like X-ray, ultrasound, MRI represented as magnetic resonance imaging, CT images represented as computer tomography. These type of images are mostly used in biomedical image processing to attain the important aspects and the color regions based upon the elements. If you take brain tumor or lung cancer, the lesions, the tumor. If you take the retinal image, mainly the blood vessels, how the blood vessels are working, like this. There are so many of applications of medical related in digital image processing. Next application is satellite imagery. The satellite image applications, let me tell you, the application is very, day by day it is changing with respect to the necessities. Now and then every country is trying to send their own satellites into the sky for the proper gathering of the information throughout the world and for different applications. The satellite imagery, what happens, the images acquired by the satellites, they are transmitted to the receiver section on the earth. It mainly, most of the applications where satellites take the pictures are not so in clear. It is somewhat difficult task to identify what it has been identified. Then we go for digital image processing, mainly to understand from the satellite images what is that area, what is its geographical area, and how it is being divided into different parts like mountains or lakes, rivers, like that. Vegetation land is there or not, barren land is available there, terrains are there, like the different structural things on the earth can be identified using the satellite imagery. Whereas when we use digital image processing algorithms, our main intention is to identify in the in the image, as per the application, what is the land acquired, what are the geographical locations, like that. In satellite imagery, digital image processing is most used. Next one, in the same lines of satellite imagery, aerial survey. This aerial survey is mainly done to identify some security things. Sometimes we do this aerial survey, has been carried out by some of the organizations to identify what is happening there during flood zones. In the flood area, some of the floods might happen there, and some of the forests. Just like aerial survey means is somewhat in the same lines of satellite imagery, but somewhat we call aerial survey to identify what are the objects that are going on and coming down there. Next one, agricultural applications. Means in the agricultural applications, the image processing helps the farmers. Even the farmers don't know what is it. The layman can also understand from the aerial survey of that in agriculture, or by looking at what are the bugs that have been eating the, we're taking the pictures itself, we can identify what are the diseases that have happened to the leaves in the crop, whatever precautions we wish to take. Next application is navigations, means geographical navigations based upon. Nowadays, this geo tag photos are very most used in the world to avoid the confusions that where that particular image is, like that. They take geo tag for the images, like that. The pictures of those areas and locations will be helpful for identifying the locations identifying the exact place of location, all those things in the navigational image processing. Other than these, there are many more applications because when it passes through different zones of applications, so many applications are there where digital image processing comes into handy and helps the researchers to identify. Some of the applications which I have not mentioned here is one of them is image steganography, image cryptography, image security, cyber security, even some of the surveillance cameras. In surveillance also, during the traffic management, in those applications also, the so-called digital image processing helps us. Some of the part of the algorithm in digital image processing helps us to identify what is happening on the streets during traffic zones, how we can identify if any road accidents happen, or if any theft happens, even the license plate which is available on the bike or vehicle can also be identified to identify any malpractice happened at that time, like a theft or some other things happened on the roads like that. This digital image processing is applied in the image steganography as well as the image security and this so-called. And also there are so many applications, they are evolving day by day, and this digital image processing has been used as a multidisciplinary algorithms in almost all the applications, starting from medicine to even what you call the simplest of the things like atmospherical changes also are confirmed by the digital image processing applications. This is how we can understand the digital image processing applications. Now moving toward the next topic of digital image processing, in simplifying this digital image processing even to the very beginners also, it is very useful. In the future scope, what is the future of digital image processing in last of the applications? Even though the digital image processing has its roots from the days of, I can say, the Egypt pictures, where in the mummies, that is so-called the pyramids, there are some image signals or image symbols have been written to as a language for communication. From it is there from the ages, or it is derived from so many of the signal processing applications. There is a lot of future also for this digital image processing. Various thing is multidisciplinary based on application. Now, image processing is utilized as a multidisciplinary type of course these days, like computer vision, depending upon image and video processing, image and speech processing, like that, signal and image processing, like that. It has become multidisciplinary course nowadays. And based upon the different types of applications, the digital image processing is excelling to do what it has been doing from the years. Nowadays, so many tools have come for doing the processing that has made it very easier. Now, very first of the most used concurrent, what you call feature of this one is the amalgamation of image processing along with the deep learning techniques like convolution neural networks, coupled neural networks, regression networks, where the iterative procedures are carried out for the purpose of training and testing the database to give us the best results in most of the applications like medical, where the training and testing of most of the samples is very necessary to come to a proper conclusion. Similarly, in satellite imagery also, this combination of deep learning has become not only, let us say, not only that what to call simple medical and all those things, even the deep learning has been involved with digital image processing in so many of the applications, starting from medical, agriculture, satellite, image encoding, image decoding. There are so many, and based upon this, we can say there is a lot of scope with respect to deep learning technologies. Next one is addition with optimization techniques. Most of the evolutionary type of algorithms like genetic algorithm and colony optimization algorithms and various meta-heuristic algorithms have been utilized in combination with the digital image processing from so many days, such as to achieve the optimal solution with respect to the process flow of the particular or corresponding so-called optimization technique. This also has been one of the promising combination of image processing with optimization techniques. And other than this, there are many more what we will discuss now in a few sentences of digital image processing future. In continuation to the previous lines, I would like to say that the image is one thing and human being is another. It is very hard to live up to an image. This one line has been coined by Elvis Presley. It is somewhat connected to our subject also here. Now, images tends to provide instant things to us, like how we process them, and the image processing has become the most searched technique these days with respect to various things have come into the market. Very first thing, in today's world of lot of technologies going on, the making a flow and implementing image processing techniques has become the very centric role in many of the giant organizations also. With respect to without thinking about what type of application they are using, what type of operations they have to carry out. Now, as the advances have become in the market, the acquisition of the information has become easy, even in the internet. Whereas, let us come to the point that image processing is today have so many implications also, and so many elements involved, so that image can be both act as an input or output based upon the different conditions, criteria, and different issues. Now, going to the point here, the image processing has been already in use for various companies in the from the olden days, but it might become a huge potential in the near future. And let us have some points to be discussed here. Is that in general, we know that image processing or digital image processing is a process of trying to understand the recognize the algorithm, enhance and manipulate the images. In general, the technology entirely deals with the two-dimensional entities with respect to applications electronically. Here, multiple computer algorithms are used by the developers to solve various algorithms. Now, with respect to various applications, the future scope has been a bright for the digital image processing. Now, let me tell this digital image processing has almost taken the lion's share in almost all the applications throughout the world. Let it be starting from medical, satellite, even automation industry also, the quality control also, the image processing has been taken. Even the applications like building, the constructions, where we use thermal infrared cameras to identify if any moisture is there in the what you call in the walls, like that. The earlier days, the one example I wanted to discuss here is one most difficult example problem thing while we build a home was to identify is there any moisture in the walls. Here, by using this thermal IR images, imaging cameras, we can also identify what is the moisture available there, and we can postpone the issues that might happen tomorrow, or postpone means we can avoid those issues. Similarly, let me tell you a few points here. In design of various systems, and we have to, the computer, whatever we use here, it should understand what is the tool we are using, how we have to use it. That also gives us very important picture. Even the applications like biometric verification nowadays, even the face detection in the mobile cameras also utilizes image processing algorithms. Even in the pattern recognition in agriculture also utilizes the image processing algorithms, like the growth of the what you call in while we have in agriculture. Let me tell you a simple example. If we have put down some type of crop there, Suddenly, in the same way, some other crop might come in between. Crop means some other plants. We call them as unwanted plants or weeds. We have to recognize them through aerial survey, and we have to remove them from the crop. This is also one of the most likely future. Tomorrow it is going to happen in one of the applications. In the automation here, in automation means if let us take the mechanical application here, while preparing for automobile industry or any other robotic, whatever the efforts, whatever the problems that might arise during to the hardware parts, if the images are taken out at each and every instant, they can be processed later such that we can remove the particular unwanted materials or unwanted things, damages that has happened during the process of the so-called machine. Now, let me give a small note here. These image processing applications will make the most of the machines which are integrated with cameras into it. They are self-sufficient actually, and they themselves work on verifying the quality of the products they are using. And we know that these image processing algorithms works very much faster for different applications than the human beings. This is also one point we have to remember. Similarly, we know that other than recognition and all those things, image processing techniques also used to extract the information like features as per the application, and it may integrate those things for other applications also. This is how we go along with the future implications of image processing. Now I would like to have a small recap of the entire digital image processing simplified process, what we have completely discussed right now. At the end, I would like to have a small recap of the entire topic, what we have just discussed for almost 1 hour in this video. That is digital image processing simplified. This video was mainly made with the intention that it will help even the beginners what is going on in this video, or what is digital image processing, what happens if a common man tries to understand digital image processing, because most of the applications are based upon the image acquisition, image process enhancement, image segmentation, image compression. Most of the applications, multidisciplinary applications in research and academics also works on this one. This main motivation was, I said, a picture is worth more than 1,000 words. Let me go with the points here. These are the basics I have discussed in this video. Next, we discussed about the main components of an image. Later, we have dealt with the stages. Stage 1, image acquisition with respect to different topics. Next, stage 2, what we discussed is image enhancement. Here, we discussed how the image is going to be made such that a process such that we can identify the hidden image, hidden features also. These are the important points we discussed about image enhancement. Later, we have discussed about main factors that involved in image enhancement. Later, we have moved towards stage 3 of digital image processing, referred as image restoration, which is almost similar to image enhancement, but image restoration is more objective than the image enhancement. Later, we have moved from image restoration to the next stage of digital image processing, referred as image segmentation. As I already informed, this image segmentation is most preferred in post-processing steps in the image processing. Later, after image segmentation problem has been discussed, we have moved to the color image processing, which is the most interested part in the digital image processing, where we go along with different color models and their applications in the real world also, which we are daily dealing with. Later, In this image processing, we discussed about how the eye works, how the wavelengths work of different colors, what is the myths we have with colors. All those things have been discussed here. Later, at the end, we have discussed with morphological image processing, stage 7, which is completely based upon shape-based mathematics and derived from morph. We have discussed about various types and operations in the basic morphological operations. Then we have deal with the applications from starting from biomedical to navigations and many more we have discussed here in digital image processing applications. Later, we have gone through the digital image processing and its future scope. What are the main things that are based upon, like multidisciplinary applications in continuation with the deep learning, that is amalgamation of deep learning and digital image processing. Next, addition with the optimization techniques. Next, and many more. We have discussed a few lines from few lines of future implications about the digital image processing, how it is going to be utilized. I hope this video has helped you a lot and try to understand a lot of things. I request you people to kindly like our channel and also kindly share our videos and subscribe our channel such that we will be encouraged to prepare more videos of more topics by making them simplified for each and every beginner. I request all of you to go through this video and provide me suggestions, whatever you think about making us more data or more content in the channel. This was about digital image processing simplified. That has been discussed with respect to the stages and along with some applications and its main facts that has been discussed in this one. If anyone has suggestions, kindly put it in the comment box. Thank you for listening.